Hello and welcome back to the Tin Barn. I'm Pragmatic Lee and I'm going to start today's video off with a question. Uh, just wondering if you've ever started a project in your shop, your barn, wherever you go out to play. Just wondering if you've ever started a project and got so frustrated with it that you just put it away. You didn't maybe give up on it, but you just put it away with the idea that you'll come back to it later and work out the kinks and figure out what was frustrating you so bad and proceed with the project. This week makes 2 years since I purchased my surface grinder. And right after getting that surface grinder, I did several projects for it. I made a new handle for the vise. I made a wheel puller, a spanner wrench, several different things for it. But one of the projects that I started to work on for it was a balancing jig to balance the wheels with. And I'd watched several other videos of people doing that and balancing wheels. And in the end, I got so frustrated, I just put it away. I couldn't get a wheel to balance. I was certain I had everything right, but just could not get it to balance. And so for 2 years, I've pretty much been using the surface grinder without balancing the wheels. Some wheels did pretty good. Others left some pretty obvious tracks, if you will, on the finish. And one of those pieces that I made, simply a V-block, thin V-block to go in the mill vise. The whole piece is at 45-degree angles. But I posted a picture of this on one of the Facebook machinist groups, YouTube Machinist on Facebook. And a friend of mine saw the picture, sent me a private message. It was Spencer Webb. Spencer has a business called Kinetic Precision. There's his mug shot if you don't know what he looks like. But one of the products that he sells or makes available is called balancing tools. It's a balancing ring to go on the hubs on the grinder wheel. And Spencer contacted me and said, you really need to balance your wheels. And he was right. The piece, I'm not sure how well you can see it in here. I'll show you some more examples later in this video. But there's obvious indications of wheel bounce. It looks almost like ripples in the finished pieces. So I talked with Spencer, and I had him to send me one of his, or I bought one of his balancing rings to go on the wheel hubs. And as it turns out, it didn't fit my hubs. I've got a Harig grinder, and the hubs on it are about 2 inches outside diameter with a 1-inch bore for the spindle. So I returned it, and but he gave me a good idea of his product gave me a good idea, and I thought, well, I should be able to make that. I did want to support Spencer, and if his rings fit your hubs, I would suggest buying one from him. But there was also a fellow named Joe Way that has a YouTube channel called Sierra Specialty Auto. I'll try to put a link to him up here to his channel, or to a video on his channel where he shows making a balancing ring. And his style is a little bit different from what I'm going to do, but when I talk about a balancing ring, this is what the end product's going to look like. I've already made a couple of these off camera, and they've worked so well. I've got 4 different hubs, and so I want to make a hub, a balancing ring for each hub. Now, what got me so frustrated doing that before, working on this project before, I had seen numerous videos where people took a masonry bit and drilled some divots in their wheels. What I did was set this up on the bridge I made, and I'm going to show you that in just a moment. Set it up, found the high spot, found the spot that always come out on top, meaning the opposite side of that was the heaviest. And I carried it, laid it, put it on my bench, spent about $10 for a nice American-made half-inch masonry bit, and I drilled a couple divots in here. Put it back on the bridge, no difference. I drilled a couple more, no difference. I wound up drilling 8 in that side of the wheel. Still, very, very little difference. I turned it around and I drilled 8 in the other side of the wheel, trying to take some material away from the heavy part. And the 2 marks on this wheel, the red mark is where I started out. After drilling all these divots in both sides of the wheel, that blue mark is all I had moved it. It just simply would not balance. I got frustrated with it. By the time I got around to drilling the 16th hole over here, that masonry bit, $10 masonry bit, was worn completely out. It wouldn't even drill this wheel any further. Now I know these are hard, grinding wheels are hard, and this one in particular is extra hard. It's a very hard wheel, but still, it just frustrated me. So I put it all away. But before we start making that wheel, I want to show you what I was working on over here. And I've got some video of making this. I think I've still got the video, but I'll show you pretty much what I did. This is all made out of steel. Steel platform, steel uprights. And in the top, I milled out a groove and put this, it's about an 1/8 inch bridge material, if you will, up here, and then actually ground a little bevel on them. After I got this completely built with no legs on it, I set it on the surface grinder and ground this flat. So I was certain that was flat. In the bottom of it, I put this little bubble level and 3 basically chair wheels, chair feet. Put them in there with adjusting knobs on the top. So I can set it on the bench, look down in there, and adjust that to level. So even my workbench is not level, I can level this. To go into balancing wheels, I made this little arbor. The taper on the hubs that I have is, let's see, it's 3 inches per foot, or a 1/4 inch per inch. Per inch of distance, a 1/4 inch taper. So this mounts on the wheel very quickly. Of course, tighten that down pretty good. Set it on the balancing jig and let it settle out. And that's the way you find the heavy part, the heavy side of your wheel. And you either take weight off of that heavy side or you add weight to the light side. So to make these balancing rings, we're going to turn to the lathe in a second. I've just bought some 1/2 inch thick by 3 inch round 6061 aluminum stock. We're going to turn to the lathe first, drill a 1/2 inch hole in this, mount it to an arbor, turn the outside diameter to where it will fit on my surface grinder where the wheel mounts, where it mounts up to the surface grinder back here. The guard has an opening around this. That ring is going to have to fit on here like such and go up in that guard. So this outside dimension on my surface grinder is very critical. So we'll turn that to the outside diameter, then we'll go over to the mill. We'll set it up on the mill and drill a 16-hole bolt hole pattern in here for 1/4 set screws. That and a little secret ingredient is what we'll use for our weights to weight the light side of the wheel. After we've done that on the mill, we'll go back over to the lathe and bore out this center so that it fits over the hub. So, apologize for the long introduction, but I wanted to give you a little background of what we're going to do. This tool, or this product we're going to make, is actually a simple little project, but I think you'll see in the end where, hopefully you'll see where it relieved a bunch of my frustration and come out with a much, much better finish on surface ground products. I've got the outside jaws mounted, or in the 3-jaw chuck now, and got our piece mounted in that. We'll need the outside jaws later on in this project when we start boring out the center. But for now, we're going to step drill into with a, I think that might be a 5/16 bit to start with, then a 1/2 inch hole. Now I'm going to mount this piece on this expanding arbor now, and these are normally meant to be used with a lathe dog and a faceplate. But what I'm going to do is actually hold this in the chuck jaws with the live center, of course, on the other end. That'll be fine for turning this thin aluminum. I'm going to step over there to the vise and get this mounted in. Now this has got a flat side on it, so I want to be sure that flat side is between 2 of the jaws. Now these are 3-inch pieces, and we want to go down to fit on my surface grinder. This needs to be 2.965. That may, of course, vary with your surface grinder, or if you've done like a lot of people have done and took the guard off, probably won't make any difference what the actual diameter of this is. Okay, I just remembered I put a new battery in this micrometer, and I always like to check the calibration after I've had the battery, or after a battery has been dead in one for a while. So I've got it zeroed back with the standard, and we're wanting 965, so we got 21 more thousandths to go. .960. I got a little bit of tolerance. I can go a little less. I just cannot be more than 9.965. So what we'll do now is take this over to the mill after I deburr it a little bit. As a matter of fact, I need to get those edges off. But we'll carry it over to the mill and start with our 26 or 16 hole bolt hole pattern. All right, I'll meet you over at the mill. All right, I'm sure there's several different ways to hold this workpiece such that we can do our 16 hole bolt hole pattern around the exterior rim. Maybe hold it in a rotary table and do it that way, advance the rotary table around, or in a T-slot, hold it down, but then you got to worry about drilling through. So what I did was just took a piece of, I believe this is probably an inch and a half round stock, flattened off the sides, 2 sides, drilled out large in one end, and then drilled and tapped the other end for a 1/2-13. I'll just mount that in the vise good and tight, and we'll set our piece in. Now I put this bolt in the lathe and with a center drill and got a good starting position. We want this as pretty dead on center. All right, now I'm going to run the spindle up on the lathe or on the mill and put the coaxial indicator in, and we'll sweep this outside, and this will pretty much max out the height of the spindle on this mill. Matter of fact, on my power drive, I've got a limit switch at the top, and that was on the limit switch. I could probably use a shorter arm here if I had to, but this will get us close, or this gets it to there. Now, I got it in a low gear. We're off about 3/1000ths with the, just spotting it over here. Let's see if I can get you turned up just a little bit. All right, so we want this needle to sit as still as possible. I'm going to manually rotate it around just for the ease of reading it. I'll set a 0 right there. Come back about halfway. All right, now I'll put it back down in the low gear. Not sure how well you can see that, but that's within 1/1000. That's plenty good for what we're doing. All right, I'm going to get set back up, get the coaxial indicator out, get the camera set back up on this area, and be right back. All right, to drill and tap the bolt hole pattern, I'm using this combination, which is the number 7 drill on the end, 1/4 tap threads at the top of the bit. You've seen me use this before in making some of the pallets. So let's get set up on our bolt hole pattern. So I've got the DRO zeroed out. I'm going to go to the bolt hole pattern. We're going to be using the XY axis. We're going to start at center. The diameter of our bolt hole pattern needs to be halfway between what we're going to make the inner bore and what the outer bore was, or the outer diameter, which was 2.965. And that is 2.594. I've already done some of these. This is why this is already set up. 16 holes. Starting angle is going to be 0. Ending angle, full circle, 360 degrees. So, whoops, excuse me. Our first hole, move it till the DRO reads 0 on both axes. Or within 1/1000ths, within a few tenths. And this will drill and tap at the same time, and I do need to stay in a low gear since it's drilling and tapping. That tap will grab in just a second. And as always, I have to tighten down an extra time. All right, we'll advance to our next hole and move the table until it reads 0. Okay, that was 15 of our 16 bolt hole pattern. We're going to leave the 16th slot empty. The reason for that is after we bore out the center and get ready to mount this on a hub, this 16th position will be used to, with a grub screw, to hold the ring onto the hub itself. I'm going to advance on over to the 16th slot and put just a little witness mark on the ring. That'll be to line it up after we bore out the center and come back to the mill. So I'm going to take this off now. And then I'm going to carry this over to the drill press and just clean up, put a little bevel or countersink in there, if you will, and clean up this edge. Then we'll meet back over on the lathe and bore out the center. Now what we're going to do is drill it out first with a 1 inch. Then we're going to bore it out to 2.222, which just happens to be the diameter of my hubs. All right, now I'm going to get the boring bar set up. Just heard a beep over on my computer. I'll go check that and come right back. And I'm going to take about 80 thousandths off. That's 40 thousandths depth of cut on each side. This little lathe can handle that fine in the aluminum. All right, I'm going to take a measurement here and set the DRO, set a dimension on the DRO so I know when I'm getting close to my desired inside diameter. And I also get the camera moved around to a better position. Okay, according to the DRO, I got about 90 more thousandths to go. I'm going to make a couple spring passes and then get another measurement. Okay, I'm down to about 100 thousandths left to go, but I've got 4 of these hubs, and I'm making these rings to match the hubs because the outside diameter, well, I've actually got 3 different style of hubs, but I've tried to turn them, as you can see on here, I tried to turn them all to a nominal value, but I still like to match the ring to the hub it's going to be mated with for life, we'll see. Now that had DRO showed about 20 more thousandths to go. I'll take 10 of them here, and then we'll start fitting to the hub. Make 1 spring pass. Well, I tell you, before I make that spring pass, yep. All right, I'll make that spring pass. Have to be extra careful here. Remember, I got those outside jaws on. All right, now we're ready to go back over to the mill and drill and tap our hole that will be for the locking grub screw. Okay, I'm sorry I forgot to turn the camera back on, but all I did was take the ring after we finished boring it out, set it in the mill vise again, lining it up with these with a couple of the holes, and then ironed it for the center on the y-axis, and drilled and tapped it just like we did the 6 sides. All right, before we actually mount the ring on the wheel hub and start balancing it, I want to show you just a little something. One of these 1/4 20 grub screws, set screws, an inch, 1/4 inch long, weighs 0.75, 0.76 grams. Not very much. A pellet from a pellet rifle, these happen to be out of my grandson's stash, lead pellet, weighs about 48, 50 grains. Let's try 2 of them or 3 of them. I'm sorry, 0.5 grains, not 50 grains. 2 of them, 0.96. 3 of them, 145. These are a whole lot cheaper than the grub screws, and they're easy to work with. But they're a little bit taller than necessary. They fit perfectly in the hole. They're 177 thousandths diameter, and let's see, a number 7 drill for a 1/4 20 is 201 thousandths. But to make these so they weren't quite so tall, in case I needed to stack 2 or 3 of them under that grub screw, I come up with this little punch and die. And I take my shop anvil or bench anvil, drop a pellet in there, and flatten it out. And what I wind up with, see if I can get it where you can see it. That's a pellet full height. And after that punch, nice and round, and will fit in that hole. So I've made up a bunch of these ahead of time that I'll be using instead of trying to fill all the holes up with grub screws. All right, so let's get our bridge set up. Now I've got the balancing jig or bridge set up so that hopefully you guys can see what will happen. This is that unbalanced wheel that I drilled some mini divots in. I'm going to let this settle down. Remember what I said at the first of this video, this same wheel, when I tried to balance it before and got so frustrated, that red marker was what stopped at the top. After drilling all those divots in both sides, 16 divots in all, this blue line is going to pretty much stop on the top, which means I only accomplished that much. All right, so that's close enough to determining what the light side is. The heavy side, of course, will be the downside. So right about where this blue mark is, maybe just to the left of it, I'm going to mount the ring, and I'm going to mount it with the this first set screw at the top. Now that probably didn't do very much at all. Remember, one of those set screws only weighs 0.75 grams. So what I'm going to start with is dropping a couple pieces of that lead on each side of the high spot and a set screw. I'll be honest with you, I've gone off camera and done this wheel with another ring and know about what it's going to take now. This is just really trial and error. And there's probably room for
at least 4 pieces of this lead behind each one of these set screws. I'm going to start with 2 pieces on each side of the high spot. Okay, I don't think I pointed it out earlier, but when you set one of these wheels up here, the way you tell if it's balanced is it don't move. It pretty much sets in place. Now that's where it settled out before. We'll try a quarter turn. And it's just barely starting to move now. We'll start over here on this side. Still needs a little more weight. So this is just like centering something in a 4-jaw chuck. You gotta make an adjustment, look at your indicator, whether it be this bridge or a dial indicator on the lathe, come back and keep making adjustments. So I'm going to do whatever is necessary here, add a few more pieces of lead behind these, and I'll bring you back when I got it balanced, and I'll show you then how it doesn't move, it sits still. I guess I probably shouldn't even took time to turn the camera off and back on for that, because all it took was one more piece of lead. But as you can see now, this is the part that was heavy before. It's setting still. I'll turn it about a quarter of a turn. And it's going to rock just a little bit. But it's set still. Put it another quarter of a turn. And again, it sets still. So this wheel is balanced now. So what difference does it make? Let's go back over to the surface grinder, and I'm going to quickly show you the difference between an unbalanced wheel and a balanced wheel. Okay, before I take this wheel off to balance it, what I want to do is grind a couple of test pieces with the wheel just like it is, which I know is out of balance. I can tell from where I did a rough grinding on here. But we're going to grind these 2 pieces together, balance the wheel, and then come back and grind just one of them and compare the 2 surfaces. All right, we're touching there, so I'm going to take 1/1000 off. All right, that didn't quite clean up from the rough grind. I'm going to keep taking 1/1000 at a time until I've got a good clean surface. All right, now to put what I usually call my finish pass on there, I'm just going to advance down 4/10 of 1/1000ths, a little less than 1/2 thousandths, and I'll step over 25 thousandths at the time. I'm sorry, 50 thousandths at the time. And now I'll just slowly go back across as a spark out pass. I'm not sure how well you can see that in the camera. Let me move it around. Okay, signs of an unbalanced wheel. Can you see back here where it almost looks like a ripple? I really can't feel it with my callous fingers, but you can see what appears to be waves in the finish. And from what I understand, that's the sign of an unbalanced wheel. Let me pull one of them off and see if I can get it any closer to you. So let's see if we can balance this wheel. I'll keep one of these just like it is,
and then after we balance the wheel, I'll do the other one and we'll compare the two surfaces. Okay, I carried this wheel over, put one of our balancing rings on it. As it turned out with this one, all it took was one set screw on each side and one piece of lead on each side, and got a good balance on it. So now we'll remount this. All right, mounted back on now. Don't want to spin it up too much without the guard in place. I'll put my tools up. I'm going to dress the wheel again. To dress the wheel, I always like to put the diamond dresser just beyond 6 o'clock, maybe about 6:30, and lock the this axis on the table so I don't accidentally bump the table and the wheel get pushed over the top. But now I'll just spin it up, gradually bring the wheel down until I can feel the grit. All right, once I can feel it, I'm going to back off. And what I like to do is go 1, 2, 3, 4 thousandths down, make a pass, 3 thousandths, 1, 2, 3, then 2 thousandths, and then 1 thousandth. And take a look at the wheel, and it looks like it's dressed good. So we'll get set up now to actually regrind our wavy piece. Remember to unlock the table. Get a little coolant flowing maybe. I'll probably make a couple passes on this until I know I've got good contact everywhere. Give the coolant time to, yeah, I think it's going now. All right, I'm going to take a full thousandths off now that we made contact, and then we'll put the 4/10 finishing pass on it after that. I'm reasonably certain I can tell the difference in the sound of the machine with the wheel balanced. Might be just my imagination, but it sure sounds better. All right. 1, 2, 3, 4/10. Stepping over 50 thousandths at the time. Now we'll just do a spark out pass going back across. All right, now I know a lot of people, when they put a straight piece like this on their surface grinder, they'll turn it at an angle so that they don't get longitudinal lines of any type on there. I wanted on this display sample demonstration, I wanted any lines to be perpendicular to the piece or in line with the piece. So I can tell you there's a big difference right there. Let me get the camera moved around here, and I'll show you the difference between the before piece and the after balance. This is the one we just took off, just reground. See the bounce in the wheels? This little spot down here, I think that's where I had some coolant on my finger or something, or some docking. This is the before. and this is the after. So I think we can all draw a conclusion from this that having a good balanced wheel will make a big difference in your finish. Of course, it's important to dress a wheel, but it's just as important to be sure your wheel is balanced, not only for your finish, but also for the bearings in your machine. Hope you've enjoyed this video. Take care, and I'll see you on the next one.